This lecture is about scientific notation. Scientific notation is used for numbers that are very large or very small as a way of representing those very large and very small numbers. A number in scientific notation form is a number expressed as the product of two factors. The first factor is a number falling between 1 and 10, and the second is a power of 10. So, in science, as we said, we often deal with very large or very small numbers. Here, I have a very large number that I can't even begin to express to you the name of this number, but there are about this many oxygen atoms, in one drop of water. So, if I am using this number and I'm trying to manipulate it with a calculation, it's very difficult. You can't get this number into a calculator, for example. So what I do as a scientist is I express this number differently. I express it in scientific notation form, and that makes it very much easier to do some problem solving with very large and also very small numbers. So let's see how we can do this. As we said, the scientific notation form is a product of two factors. The first factor is a number between 1 and 10. So how do I get that number between 1 and 10? What I do is I take the number that I have and I look for the decimal. And if it's a number like this, 8,653,000, if there's no decimal, I put the decimal where it should be. Okay? Then what I'm going to do is I'm going to move my decimal to create a number between 1 and 10. So in this particular case here, I move the decimal 2 places and create a number 5.2, which is between 1 and 10. And here I move my decimal 1, 2, 3, 4, 5, 6 places, and I create a number between 1 and 10. Then I count. In my first example, I moved my decimal 2 places to the right, and in my second example, I've moved my decimal 6 places to the left. So, in scientific notation, I have two factors that are products. One is a number between 1 and 10, and we've seen how we've gotten that. The other is a power of 10. So I want to multiply my new number by a power of 10. What power of 10 do I use? The power of 10 corresponds to the number of times that you moved your decimal. So if I move my decimal 2 times, it's times 10 to the second. If I move my decimal 6 times, it's times 10 to the sixth. Now, if I move my decimal to the right, my power of 10 is negative. If I move my decimal to the left, my power of 10 is positive. So in my examples that I had been using, since I moved this 2 places to the right, I have a number that I created between 1 and 10, 5.20, and my power of 10 is times 10 to the negative 2 because I moved my decimal 2 places to the right to get this number between 1 and 10. And since in my second example, I moved my decimal 6 places to the left, my power of 10 becomes times 10 to the sixth. It's a positive 6 because I moved it to the left 6 places. Okay, let's try some more examples. Here I have a number 520. If I want to change this to scientific notation, I move my decimal 2 places to the left to create a number 5.20 times 10 to the 2 because I moved it 2 places to the left. Here I have a number that I create in scientific notation by moving the decimal 6 places to the left, creating the number 8.653 times 10 to the sixth because I moved my decimal 6 places to the left to get this number. And finally, I have this number 0.0037. If I want to express that in scientific notation, I move my decimal 3 places to the right, and since I move my decimal to the right, my exponent becomes negative. So I move my decimal to get a number between 1 and 10, which is 3.7, and I moved it 3 places to the right, and so my times 10 to the negative 3. Now remember, we just talked about are significant figures, and so we want to make sure that we are expressing our answers to the appropriate significant figures. So if I go back and I look at this number that I started with, 520, you'll see that 520 has two significant figures. Remember that trailing zeros are not significant if there is no decimal. So this number started with two significant figures, so my answer has to have two significant figures, 5.2 times 10 to the negative 2. If we go back and we look at this number, again, this number only has four significant figures. Okay, these three are not significant. Again, trailing zeros are not significant if there's no decimal. When I move my decimal place, I also want my answer here to have four significant figures. So this becomes 8.653 times 10 to the 6th. And one more time, if I go back here, since leading zeros are never significant, I would express this as 3.7 times 10 to the negative 3. Two significant figures, two significant figures. So make sure, that your answer, if you're changing a number to scientific notation, that the number that you're expressing between 1 and 10 is in the proper significant figure based on what was originally given. If the original number has two significant figures, then your number between 1 and 10 has to have two significant figures. If your original number has four significant figures, then your number between 1 and 10 has to have four significant figures. Okay, the last thing we want to do is just calculate in scientific notation. So oftentimes you're going to be using your calculator, and if you don't know how to punch numbers into your calculator to get scientific notation, please make sure that you see me either before or after school, and I will help to show you how to do that on your particular calculator. Every scientific calculator is a little bit different. So if you're having trouble expressing numbers, punching them into your calculator in the form of scientific notation, come and see me and I'll help you with that. But if you don't have a calculator, you can multiply, divide, add, and subtract numbers that are in scientific notation very easily. If I'm going to be multiplying, the first thing that I'm going to do is I'm going to multiply my first factors, and then I'm going to add the exponents. So in this particular example, I have 3.2 times 10 to the negative 3 times 2.1 times 10 to the 5th. I'm going to multiply 3.2 and 2.1, and I'm going to get 6.7 when I do that. Now notice, two significant figures times two significant figures, so my answer is in two significant figures. And then I just add these exponents. Negative 3 plus 5 gives me an exponent of 2. Division, same premise. I'm going to divide my first factors. So 6.4 divided by 1.7 gives me 3.8. Again, two significant figures, two significant figures, two significant figures, right? So make sure that we're using appropriate significant figures. And then instead of adding the exponents if you're dividing, you're going to subtract them. So 6 minus 2 gives me 10 to the 4th. Now it's a little bit different when we add and subtract. When we add and subtract, this number, the exponent, the second factor, has to be the same number. So what I have to do is I need to change this number so that we are expressing both in the same factor of 10 here. Okay? So what I need to do is I would just move this decimal to 0.58 times 10 to the 4th, right? Because if I'm moving this decimal here, I'm multiplying by a factor of 10. Okay? And so I get 0.58 times 10 to the 4th, and then this stays as 2.16 times 10 to the 4th, and then I can just add these two, the first factor together, and of course it becomes times 10 to the 4th. I will do the same thing when I'm subtracting. If this were a subtraction problem here, I would again move my decimal I would subtract my numbers, and again, I would have it to the same decimal. Okay, so when we reconvene in class, we're going to be practicing doing a few scientific notation problems, and hopefully you'll get the hang of it then.